Hello guys, welcome to She Codes. So in our top 100 code series, our next problem 31 is for binary to octal conversion. The binary number system is composed of two symbols 0 and 1 with the base value 2, and the octal number system has base value 8 comprising digits from 0 to 7. Now, for the process of binary to octal conversion, we can follow two methods. First, we can use the built-in Java method toOctal string. Now, this is a built-in method in Java. This method returns us the string representation of that argument number as an integer in base 8. Now, this method is a built-in method which converts the given integer into octal number with base 8. And the second process is using user-defined functions to convert the binary number to octal number. So, in this video, we will discuss the second method, which is a user-defined method. So, the process will be, first we will convert our binary number to decimal number, which is base 10, and then that decimal number will be converted to octal number. So let's get started with the Java program. Okay, so let's get started with the program. Now here the process I discussed involved two minor processes, which is first we need to convert a binary number to decimal, and then we will convert our decimal number to octal number. Okay, so first I have declared a variable binary which will store the binary number which we have to convert, and this process which I am highlighting over here is the process of conversion of binary to decimal. Okay, we have done a detailed video on how you can convert a binary number to decimal. You can check the link in the description box or at the top right corner. Okay, now I'll explain again. So here I have taken a variable decimal, okay, which will store the calculated decimal value. Below is a while loop. Now this while loop will run until the value of binary is 0, okay, until the binary number which was given by user is 0, the loop will run. Okay, now here I have a variable temp. Now why we are taking out this remainder, why we are using this modulo operator, because we need to calculate, we need every single digit of that binary number. Okay, so the process is simple. If you have a binary number 111, okay, for example, if you have a binary number 111, so the calculated decimal value is 7. How? Every digit of this binary number 1, every digit, okay, every digit will get multiplied with 2 to the power of that index of that number. Okay, so here you can see, as I am highlighting, 1 is multiplied with 2, okay, 1 is multiplied with 2 and 1 is multiplied with 2 into 2 to the power the index of that number. Okay, so 2 to the power 0 into 1 plus 2 to the power 1 into 1 plus 2 to the power 2 into 1. So this is the process we will follow to convert a binary number to decimal number. Okay, so here I have a temp variable which will give us remove every single digit from the whole number and give us the remainder. Okay, so for that I am using modulo operator. Now below this decimal variable will store the calculated value. Okay, so for that this temp variable have every single digit, it will get multiplied with 2 to the power n. Okay, so the initial value of n is 0. Fine. Now this will get multiplied with 2 to the power n. Math.pow is a method where we can get the calculate the power of a number. Okay, so here we get the decimal value, है ना, and then we will reduce the binary number by dividing it by 10, and every time the loop is running we are incrementing the value of n until the value of binary is 0. Okay, So this was the process of converting a binary number to decimal number. Now the next step, step 2, includes decimal to octal conversion. So again we have done a detailed video on how you can convert a decimal number to octal number. It is present in our top 100 code series. If you haven't checked the playlist, go check out our cheat codes, and the link has been given in the description box. Okay, now the step 2 involves the conversion of decimal to octal, where we will get the final result. So here I have taken an array octal. Okay, now again I am using a while loop. Now this while loop have a condition that until the value of decimal is 0, this while loop will run. Now what we are going to do here is, as I say in every conversion video, that you have to remember the base value of that number, okay, of that number system. Since octal has a base value 8, okay, octal number system has a base value 8. So what we will do is, we will divide the decimal value by 8, and the remainder we will get, we will store it in our octal array. Okay, and we will increment its index every time while the loop is running. Okay, so this process is very simple. How you get an octal number from decimal number is, you divide that decimal number by 8 using modulo operator. Okay, so you will get the remainder, and that remainder will be stored in this octal array, and then we will reduce the value of decimal number. So this is how you get the octal number. Now the octal number you get is in reverse order. Okay, so for that we are going to use a for loop over here. This for loop will reverse the octal number and will give us an original value. Okay, so let's run this program and check the output. So here if I enter 111, okay, so I get octal number is 7. Again if I enter 111 and 01, okay, so this is a binary number, and we will get the octal number 35. So this is how a program works for binary to octal conversion. Do subscribe cheat codes, and thank you.